All right, so day 2 of neural net work for this class is all about activation functions and forward propagation. So we'll talk about both of those this lesson. So the first thing I'm going to talk about though is activation functions. Now I know we talked about the heaviside function last class. So the heaviside function is simply, I mean, it looks like this. If you had to visualize it, basically if x is or whatever you're passing into the function itself. Again, we did a summation from I is equal to 1 or 0, I should say, to 2, I think is what we do in wi xi. That was my x last time, so that's what you're passing into the function. But whatever you pass into the function, if the value is greater than 0, then you give it a 1. If it's less than 0, you get a 0. So it should look something like this, where 0 if x is less than 0, and 1 if x is greater than, and you can put equal sign there so it gives so it goes up right at 0. The next one is the sigmoid function, right? Sometimes referred to as the logistic function. And again, that looks a lot like the heaviside function, except where the heaviside kind of jumps right up at 0, and in other words, your neuron is either firing or it's not firing. So that's sort of the idea behind the heaviside function. In this case, you got like a level of firing, right? You could be down back here a little bit, and you could still get a little bit of, I don't know, firing, if you will. So in other words, it's not 0 here. It's something greater than 0 but less than 0.5. So that's the idea behind that one. So let's look at that function. So it's just a simple function, 1 plus, I guess not so simple, but e to the negative x. So it looks something like that. Okay, so those are the two main ones that we'll use in this class. Go to the Jupyter Notebook and you can check out a ReLU function, and I think the hyperbolic tangent. I think the hyperbolic tangent looks a lot like the sigmoid, except for I think it goes down to -1. Anyway, go there and check those out. I think I even give you a visualization of what each one of those look like. Okay, so the next thing we're going to need, and we're going to need this probably starting, I think, next class. I'm trying to remember what the third lesson was all about, but probably next class we're going to need this sigmoid function. So we're going to need the derivative of the sigmoid function. So let's do the derivative. So there's the function 1. So just to recall, I'll bring it down here. Sigmoid of x is equal to 1 over 1 plus e to the negative x. So let's do low d high minus high d low over low squared. So low, so 1 plus e to the negative x. D high, in this case, would be the 0. So we got 0 there. Minus high, which is 1. D low, so that's a 0. And then e to the negative x. E to the negative x times -1, all divided by low squared. So 1 plus e to the negative x quantity squared. So let's simplify this a little bit. So yeah, I got a minus and a minus. So that'll turn to e to, and obviously this whole thing goes away. E to the negative x divided by 1 plus e to the negative x quantity squared. All right, let's break this sucker up. So I'm going to break it up into 1 over 1 plus e to the negative x, and then multiply it by e to the negative x over 1 plus e to the negative x. And we notice, hopefully, right away, that this is simply the sigmoid function, right? So it's just simply the sigmoid function. So I'm going to call this sig of x instead of writing all that out. And this next part, we're going to write by saying, let's see, I'm going to put a 1 plus here, and then I'm subtract 1. So I'm adding 1 and subtracting 1 to the numerator. And that allows, so I'm going to rewrite this guy after putting that +1 and -1 in there. I'm going to rewrite it as 1 plus e to the negative x over 1 plus e to the negative x, right? So I'm kind of doing the opposite of this. You know how you got 1 plus, let's see, 1 plus, let me think of 1, let's see, 1 over 2 is probably not a good number. Let's use 4. 1 plus 4 over 3 over, I don't like 2 over 4. This is equal to 1 plus 2 over 4, right? Or you could write it back this way. So I'm going back this way. So I'm taking the denominator and putting it underneath that piece, and I'm putting it under that piece. So that's the idea. I'm taking this denominator and I'm putting it under just this piece here first and then put it under that piece. So then minus 1 over 1 plus e to the negative x. And then we notice, hopefully, that this is 1. That's just the number 1. And this, again, is sig of x. So putting all this together, we note that the derivative of the sigmoid function is simply equal to, let's see, that's the sigmoid function times 1 minus the sigmoid function, which is, I don't know. I don't know if you guys think it, but I thought it was a little weird the first time I saw that, but it's pretty neat. So we're going to need this result in a couple, probably next lesson or the lesson after that. I think it's when we start trying to take the derivative of this stuff. So it's probably it's probably next lesson. Yeah. Okay. Anyway, bottom line is we'll come back and use that later. But again, activation functions, sigmoid, heavy side, those are the two that we're worried about. You see what the derivative is. The sigmoid is the one that we're going to use. The logistic one is the one that we're going to use. All right, that's all we got for this lesson. Hopefully you got something out of it, and we'll see you here in a few minutes to talk about forward propagation.